In this episode of Watkins Waggles, we're going to be looking at covalent bonding diagrams and how to draw those, how to spot them in exams, and how to make sure we get full marks every single time. Okay, so this is what this video is focusing on, covalent bonding diagrams. First thing to note is, they're not going to actually tell you in the exam question that you need to draw a covalent bonding diagram. What you might get, if you're foundation tier, is you might get a question that looks like this. Two circles overlapping. Remember, caring, sharing coconuts. Coconuts are circular. The minute you see overlapping circles, it has to be a covalent bond. Now it tells you at the top some information about what they're talking about. It says the bonding in iodine is similar to the bonding in chlorine. It asks you to complete figure 4. First thing to notice is on our top tips, make sure you look out for questions that say complete. As soon as you see that word, you're going to have to do something on a diagram. Okay, so complete means do something to a diagram. You've been told to show the bonding in iodine. Okay, that bonding could be covalent, ionic or metallic bonding. But let's face it, we've seen our overlapping circles, we've thought circles, coconuts, covalent bonding, and we've only got to show the outer electrons only. So we're never going to have to draw all the shells, just the outermost shell. Now they've asked us to do chlorine. Okay, how do we do this? Sorry, it's similar to bonding in chlorine. They've asked us to draw the bonding in iodine. So how are we going to do this? First thing we need to know is how many electrons are in that outer shell. So obviously in the exam you have a periodic table. Find your periodic table, find iodine. I know that iodine is a non-metal, so I'm looking over on the right hand side of the table. There's I for iodine here, and I'm looking up and it's in group 7. Group 7, 7 electrons in the outer shell. Before I even think about that, I'm going to write down here that it's 7 electrons, just to remind me. I've got an overlapping circle. In nearly all cases, if I just put a dot and a cross in the overlapping circle, that's my covalent bond. Okay? I need to have full shells of electrons once two chemicals have bonded. So if I now just fill up the rest of this shell, how do I know how when it's full? Well, if we think back to our little mnemonic, I ate, so I'm full. When I eat, I am definitely full. So that means there needs to be 8 electrons in each shell. We need to focus on the whole circle. So there's 1, 2 already, 3, 4, 5, 6, 7, 8. I'm making sure that I put them definitely on the circles. And then same on the other circle. I've already got 2 within this circle. So 1, 2, 3, 4, 5, 6, 7, 8. Doesn't actually matter at all that I've used crosses all the way through. Perhaps I could have used dots on this one to show the electrons in each of the different atoms, but it doesn't matter. As long as they are on the lines and as long as it's obvious what you mean, that will qualify for full marks. So I've got a shared pair of electrons in the overlap, put a dot and a cross, and then fill up the remaining shells. Does it match up with what I think? Iodine has 7 electrons in its outer shell. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. They've shared 1 each. To get the bond, there's my 2 marks. 1 mark for having the overlapping circle filled in correctly, 1 mark for having the remaining shell filled in correctly. Let's see some other examples. There's many different examples of this that you could be asked to do. There are some standard chemicals that you are supposed to know. They're on your checklist. One of those is water. Okay, water is H2O. So if we think about what H2O actually means, we've got 2 atoms of hydrogen and 1 atom of oxygen. Now hydrogen is a little bit unusual in the fact that it only has 1 shell in total. It's always drawn as a smaller circle in an exam question. If you're foundation, they might give you the element symbols inside the circles. For higher tier, they probably won't. But again, we've got overlapping circles. So the first thing we're going to do is simply put that dot and a cross in those overlapping circles. As I said, hydrogen is unusual. It only has 1 shell, and 1 shell only needs 2 electrons in order to fill it. So that one is absolutely sorted. So just think hydrogen, only ever 2 electrons. Oxygen, again, think about, I ate, so I'm full. It's already got 1, 2, 3, 4, so I just need to add 5, 6, 7 and 8. a total of 8. They've all got full shells. The overlapping circles contain the shared pair of electrons. So I've definitely drawn a covalent bond. I've all got full shells. That diagram must be perfect. If I want to double check, I can just check on which group oxygen's in. Oxygen, find it on your periodic table, it's here. If we look up, it's in group 6, so it has 6 of its own electrons. 1, 2, 3, 4, 5, 6. 1 each from the hydrogen, that's perfect. These are some of the standard diagrams. If you learn them, you'll be able to do them every time. Let's have another look at some more exam questions. So here's another example. There we go. Similar style of question again. We've got the word complete at the beginning of the question. Don't forget to complete the diagram. The other clue is that I've got some marks down here on the right. This is not just a diagram. This is not just a picture. I've actually got to do something, but there are no lines to write on, so it's not that obvious. So look for the marks down the right hand side. There's 2 marks here. Something has to happen in this space. It's telling me to show the arrangement of the outer shell electrons of the nitrogen and hydrogen atoms in ammonia. It doesn't matter one little bit if you don't know anything about ammonia, and it tells us to use dots and crosses to represent the electrons. Sensible to use dots for one, crosses for the other. Overlapping circles. What do we do first? Every single time, put a dot and a cross in those overlapping circles. That's one shared pair of electrons, that's one covalent bond. It's quite a small space. I've got an A5 exam paper. Yours will be a bit bigger. Make sure that those dots and crosses go inside the overlaps. If they go outside, you lose marks. Okay? Right, hydrogen. We said it's a little bit unusual. We talked about the fact that it only ever has 2 electrons in its shell. If we look at our example, that's exactly what it's got. Nitrogen, 1, 2, 3, 4, 5, 6 electrons within its shell. I 8, so I'm full. We need 8 in total. 1, 2, 3, 4, 5, 6, 7, 8. Those extra ones can go anywhere on the shell as long as they are not in that overlapping circle. That's the correct answer. We're totally sorted. If I wanted to double check, I can look to see how many electrons nitrogen should have. I've given it 1, 2, 3, 4, 5. The crosses are on the nitrogen shell, so those are nitrogen's electrons. There's nitrogen. It's in group 5, so we know we're correct. 2 marks, absolutely perfect. But what if you're higher tier? Can it get any more difficult than that? It can get slightly more difficult, just with the example of oxygen. So this question, again, exactly the same. We haven't got a written space. We haven't got any lines. Loads of students miss this question completely. There's the command word complete. There are the 2 marks. The next question starts here. Describe the structure of a metal, and there's 3 marks. So if you skip straight to here and you just skim over this and you don't pay attention to the diagram, you'll miss out on those 2 marks. So this is higher tier. You'll notice they haven't given you any element symbols in the middle. You could do. You could put the O's in, makes it look a bit like eyes, but probably the reason why they don't do it. And it says you need to show the outer electrons in an oxygen molecule. This is not quite as simple. If we just put one shared pair of electrons, we won't end up with the correct answer. The reason for that is because with oxygen having 6 in its outer shell, it actually needs to share 2 pairs of electrons. Oxygen molecules are connected by a double bond. That means 2 shared pairs of electrons. Again, having a small exam paper means I haven't got that much space. So let me show you on a slightly larger example. You'll have an A4 exam paper. You will have plenty of space to do this. So oxygen, they've given us 2 overlapping circles. We need 2 shared pairs. So rather than just drawing a dot and a cross, I draw 2 lots of dots and crosses. Oxygen is in group 6. Okay, 1, 2, 3, 4, 5, 6. Okay, 7, 8 come from the dots. I've now got 1, 2, 3, 4, 5, 6, 7, 8. That is my full shell of electrons. On this side, 1, 2, 3, 4, 5, 6, 7, 8. Doesn't matter where I put them, as long as those extra ones do not end up in the overlap and they're actually on the circles. So, Oxygen's in group 6. 1, 2, 3, 4, 5, 6. There are 6 electrons on that outer shell. 1, 2, 3, 4, 5, 6. 6 electrons. 8 on both in total. That's oxygen. It is a little bit unique. You're probably worth learning that one off by heart. Every other example that you're going to be given is going to have just one dot and one cross in that overlapping circle. Good luck. That's how to make sure you maximise success on covalent bonding diagrams. Don't forget, look for the words complete, look for the marks where there's not a written space, and make sure you actually tackle it. Happy revising.